tres.
Good morning, teacher and classmates. Today we talk about artificial skin. Next, we started to what is artificial skin. Artificial skin is a man-made material designed to mimic the properties of natural human skin. Artificial skin can be made from synthetic materials or biological components or a combination of both, and it helps promote healing or reduce infections or support tissue regenerations. Why is important? Artificial skin is important because it plays an important role in a modern medicine. It provides a protective barrier for wounds or reduce the risk of infection, and it can save lives by replacing damaged skin and preventing complications. Next. And now we talk about origin and emergence of artificial skin. Artificial skin was first developed in 1970 by Dr. John Barker and Dr. Johannes Janas. They created a synthetic material to help burn victims when natural skin grafts were not enough. It was first used successfully in the 1980s. They create a material of collagen and glucosaminoglycan. That is a kind of sugar molecule, which helps simulations the body's one and body's one tissue regeneration. Next, please. And finally, I talk about why artificial skin emerged. Artificial skin emerging because they are important advance in biotechnology and material science in the 20th century made it possible to create synthetic alternatives that could protect ones and support healing. And another technology advance in artificial skin, we have improved biocompatibility, cells regenerations, multi-layer design, controlled drug release, and finally electronic skin. Thank you.
Good morning, teacher. I'm going to talk about the present-day applications about artificial skin and electronic skin in medicine first. And I will say that in medicine, artificial skin is a man-made material used to replace or support damaged skin. And obviously, it's used for treating burns, wound, or surgical procedures in humans. So the purpose in medicine is to protect the wound area, and also helps the body heal when natural skin is too damaged because of an accident, for example. And it reduces risk of infection and fluid loss. Finally, it promotes faster healing and better recovery. For example, in this figure, you can see that there is in the image we can see that there are two parts, well, especially two parts. There is the epidermis and the dermis. Until these days, epidermis is what medicine and scientific are developing, but dermis is are studying, what they are studying until these days, because in the future advances, they want to achieve sense temperature or pressure and connect with nerves or devices. So because this is what they want. Also, the body only provides these types of sense or connect with the nerves, not this inner property when you only use for medical burns or bones. Okay, the next. Now, artificial skin in robotics and prosthetics. Well, in this type of artificial skin is electronic skin. in simple words. So in electronic skin, we can say that I can say that it's a flexible, stretchable, and sensor field material that mimics really real human skin, and is used to give robots and prosthetic limbs the ability to feel and interact with their surroundings. It's like a skin bath for made for the robots only, and it simulates the skin as the text says. And the purpose and importance is to help robots detect pressure, touch, temperature, and movement, and allows prosthetic users to feel more natural sensations, gain better control and feedback from the artificial limb. Okay, in artificial skin in wearable technology and sensors. We know that wearable is something that we is something that is disconnected. Okay, it hasn't cables or anything. So in this type of artificial skin, we can see that it's soft, flexible material and with built-in sensors. And it mimics real skin to monitor health by sticking directly to the human body. Uh, in the main functions, it could detect vital signs like heart rate, body temperature, sweat and hydration levels, muscle movement, and it could send data wirelessly to smartphones or med system, for example. About the key features is the biocompatibility to save to wear on skin, stretchability more without breaking, comfort being lightweight, real-time sensing, continuous health tracking. And the benefits, well, I will talk about this image because it's important, I think. We can see an e-skin patch for health monitoring that is here. It's wearable. As you can see, there is no cable, and it's soft as the text says. Is one of the features. And in this case, it e-skin patch. The function is to meet to yes, it detects vital signs like the glucose and also had the blood pressure. Okay, the benefits finally in this occasion about wearable technology and sensor is the early detection, chronic disease monitoring, fitness tracking, and patient care. Okay, the next. Well, now I will have here an article about the recent development of electronic skin, but only in robotics and prosthetics. So in this article, review that recent progress in electronic skin for using wearable devices, robotics, and prosthetics. Key skin needs to be soft, stretchable, and able to heal itself to handle long-term use and fit different shapes. It should sense touch, pressure, hair, and movement to help monitor health. And they are developing a wearable for only robots, and also to simulate an artificial limbs to interact with their surrounding. For health device, I need also detect both body signals. So here I add um, a box, a kind of a box with all the materials that they are using, and also what's the function that they want to achieve with with this technology, like the pressure, the strength, the temperature, and the sleep sensor. I don't know if you can maximize the image, but there is the box is here uh, near to the text. So there are the functions that they want to achieve, as I said, with that technology that they are developing. So that's it.
Okay, continue with the topic. I talk about development and manufacturing. The first is material selections. The first critical step is selecting materials that mimic the flexibility, texture, and biocompatibility of human skin. Polymers like silicone, polyurethane, and hydrogels are commonly used due to their elasticity and ability to hold moisture. For more advanced application, bioengineered materials or based matrices are preferred because they support cell grow integration with human tissue. With the next, integration of sensors and application of protective layers. In integration of sensors, to replicate the sense of touch, artificial skin often includes embedded sensors that detect pressures, temperature, and even pain. These sensors are made from five pieces of electric materials or nanowires and are arranged in a network that allows for high sensitivity and spatial resolution. They challenge lies in maintaining flexibility and stretchability without compromising the sensor's performance. Okay, with the application of protective layers and specialist coating are applied to enhance the skin's durability and functionality. For instance, antimicrobial coatings help prevent infections, while hydrophobic or variable layers control moisturization. So coating also improve addition to biological tissue or increase connectivity for better sensor communications. Okay, uh, another stop is connectivity to device or nervous and functional testing. And with the letter C, for prosthetic application of human machines, interface, artificial skin must connect to external device or the nervous systems. This involves integrating microelectronic components that transmit a signal from the sensors to the brain on a computer. In advanced research, neural interfaces are being developed to allow two-way communication between artificial skin and the nervous systems, enabling real-time feedback and control. And in functional testings, finally, artificial skin undergoes rigorous testing to evaluate its mechanical properties, sensory accuracy, and biological compatibility. These tests simulate real-life conditions such as repeated stretchings, exposure to different temperature, or interaction with human tissue. Functional reliability and long-term durability and safety are critical factors before clinical or commercial use. Okay, let me add something to this topic, advantages and challenges. And challenges, still expensive to produce on a large scale, limited sensory and durability compared to real skin. Connecting to the human nervous system is complex, sorry, and not fully solved, and needs more development to be used in real-world medical environments. Advantage: a restore touch to people with prostheses can be used in robots to make them more human-like. Useful in healthcare monitoring like hair rate or hydration levels, and materials can be flexible, lightweight, and even biodegradable. Okay, finally, conclusions. Artificial skins is a powerful innovation that merges technology, biology, and engineering. It plays a key role in improving the life of people with prosthetics, enhancing robotics, and opening the door to futurist applications in medicines and wearable technology. Thus, its face challenges in cost and full integrations. The future of artificial skin is promoting and represents a major step toward merging machines, sorry, machines with human sensory capabilities. Thank you. And we continue with the PPTs, these questions. And thank you. Ya lo pausé ya. Ahora sí pueden hablar. No, hombre, pero
Así ya no creo que está bien, que le preguntaron si el material también.
no, no, el material no.
Ajá, y Frecia dijo que ya no.
Ah, ya, entonces
Lo de
solamente
la
es de
resolución.
posición.
Ajá.
Sí, solamente pues ya.
Pero espérate,
Ah,
voy a
ya.
reanudar para mostrarle que le hemos hecho ya.
Ah, sí, 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 mejor. Solo muestra.
Ya está ya.
Ya.